I want to talk about 2-4. Okay, this stuff is not. I don't think it's going to tax you. It's not going to be extremely hard, but it is something that we use every single day, whether it's inside geometry or outside geometry. Okay, and it's called deductive reasoning. Okay, and we'll talk about two things called, there are two laws. One's called the law of detachment, and one's called the law of syllogism. We're going to talk about those and how we approach this. And I think you're going to find out that it's somewhat simple if we use like elementary type examples. Okay, and you'll see some elementary type examples here in a minute. But then we want to take the process and overlay that process into geometry, and then the facts that we know about geometry, the facts that we know about other math or other branches of math, and how that then yields new information for us inside this course. Okay. Deductive reasoning is the process of reasoning logically from given statements or facts to a conclusion. Okay. Huh? Can I simplify it? That's what those next two bullets say. Deductive reasoning is making a conclusion based on already known facts. And those facts are going to be definitions, postulates, and theorems. Okay. With this slide, I'm talking about this all the time, but this class is going to be very, 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 very hard if you don't know your vocabulary. Okay? We're going to see some questions here in a little bit. That becomes very hard because some of us don't know our vocabulary very well. Okay? And it's hard to talk about relationship between supplementary angles and linear pairs and straight angles and adjacent angles, okay, if we don't know definitions. Okay? For instance, when I ask a question, I'll give you the conditional statement. If two angles are a linear pair, then they are supplementary. That's a true statement. Okay? But then if I say the converse of that, if two angles are supplementary, then they are a linear pair, that's false. And the only way I can really answer that as being false is if I understand that the definition of linear pair is two adjacent angles that form a straight line. And if I know the definition for supplementary just being two angles that sum to 180. Recognize that the conditional statement, if two angles are supplementary, then they form a linear pair. Those definitions in that statement don't jive well together. Okay? And that's how I can come up with a counterexample and give a false statement. If I don't know those definitions, I'm really going to struggle. Okay? But deductive reasoning is simply just coming to a conclusion based off the facts. This is what lawyers do. Okay? If I'm going to convict somebody of a crime, I have to have facts of being able to convict. Right? I have to have an alibi. I have to have DNA proof. I have to have, somehow to prove like association, stuff like that. Okay. So we're going to use previous known facts, and in the math world, it's definitions, postulates, and theorems. Okay. Generally speaking, in layman's terms, it's simply coming up to a conclusion using the stuff you already know. Okay. That's deductive reasoning, and we start deductive reasoning by talking about two concepts. Okay. If I were to give you a statement, okay, let's just give you a statement first, and then we'll talk about this law and actually see if it makes sense on what this law is saying. If I tell you, let me say, I give you a conditional statement that says if it is Wednesday, then it will rain. Okay? If it is Wednesday, then it will rain. And I tell you that the Weather Channel told me it's 100% chance it's going to rain Wednesday. So that's why I came up with that condition. I say that's a true conditional statement. If it is Wednesday, then it will rain. Okay? Now, I give you an additional statement. I give you one more piece of information. And I tell you, today is Wednesday. You can spell it right. Okay. The conditional was, if it is Wednesday, then it will rain, or it is raining. Okay. And now I tell you, today is Wednesday. what conclusion can you make?
It's going to rain.
It's raining. Okay? Or it will rain. Yes. Okay? Does that make sense? Is that pretty easy?
Yeah.
I give you a true conditional statement. And then I give you a second statement. Okay? I give you basically a second statement that matches your hypothesis. Okay? This statement here matches that hypothesis, right? Okay? If that happens, you can make a conclusion then. You can come up with the fact that it will rain. Okay? So let's say this. Let's say I give you
Seems easy.
if two angles are vertical, then they are congruent. And then I give you a picture that looks, that's terrible. A picture that looks like that, and I'll talk about that angle right there where my cursor is, and that angle right there. Are they vertical?
Yeah.
Okay. So I gave you a piece of information, a statement somehow, that matches to this, right? So if they're vertical, then what is the conclusion that you can make about those two statements given this true condition?
They're congruent.
They're congruent. Okay. Is that all right with everybody? Okay. Hopefully the law of attachment is extremely easy. It says that the hypothesis of a true conditional is true. What they're saying about that is that statement that I give you. Let's go back to maybe the raining one on Wednesday. So go back to this one. Okay. When it says if the hypothesis of a true conditional is true. So this is a true conditional. They're saying this is the hypothesis being true. If this, they're just saying if this, it's a better way for them to say this second statement matches the first statement. First statement's hypothesis. If they match, then this conclusion here is true for that new statement.
Does it say law of detachment or low of detachment?
Law, L-A-W.
Okay.
So you see a couple of these. Like I said, we're going to do some elementary ones. I think it's like the raining on Wednesday and stuff like that. That's kind of an element when I say elementary. There's no math involved in that, okay? At least math concepts. The way we're thinking is the mathematical thought patterns, okay? Logic is math, okay? So that is in there. But this phrase here, this given phrase here, doesn't have any math in it, right? Other than the way we're thinking, the way we're processing it. Okay. But it says if a student gets an A on the final exam, the student will pass the course. Maybe in my syllabus I present that information to you. So I'm telling you that's a true condition. Okay? And then I've got a student named Felicia. She gets an A on the history exam. What is the conclusion you can make about Felicia? She's passing the course. Okay? Because this is a true statement. Okay? Hold on. This thing's been messing up on me all day. What?
I'll just tell them if they want to answer questions, just yell it out.
Yeah.
Right next to it. That was good.
I would much rather have 14 people screaming answers at me than one person always raising. I'm not a big fan of raise your call or all people like that. Give me what you know. So if a student gets an answer to that phrase right there, and that phrase right there, they're not word for word, right? But conceptually they say the same thing, right? So they match. We're saying they're matching. And if those two things match, then in regards to this statement here, okay, in regards to that statement, we can make this conclusion up there. Alright? So Felicia's going to pass the course. Do another one. Put some math into this one.
We're going to use this in real life.
You use it every day.
Right.
You do. You don't think you do. You don't process things at this pace during your life, but you use deductive reasoning and the law of attachment all the time. Okay? You know, think about this. You know because of previous information if the bell rings, then you get up and go to 7th period, right?
Yeah.
Okay. And 20 minutes bell's gonna ring. What are you gonna do? Okay, so when that bell rings, that bell is your second statement that matches up the if then statement, right? And that matches the hypothesis. So then you know the conclusion. What you get up and leave, right? Okay. So we do it all the time. It's how we interact. It's how we live. It's how we make decisions all the time in life. It's just kind of subconsciously, right? And what this course is about is trying to get us to not let that stuff be subconscious. Just kind of think about the way we think. And that's going to help us immensely in understanding the system of math. Okay. Here it says if a ray divides an angle into two congruent angles, then the ray is an angle bisector. That's true. Hopefully we've talked about that in the past, and you can agree with that. Okay. Now I get this second statement down here. This thing's messing up again. Awesome. Like notice when I touch over here, like that's not where I'm touching. What?
They say in my brother's book where he talks about math class and you, and he said that if you really wanted to, you could throw him through a wall.
Throw you through a wall?
Yeah. He said.
I wouldn't do that to you.
He said I shouldn't be as annoying. Oh well. He said it's good.
I apologize. We'll get this fixed here in a minute. Alright. I don't want to be on that one. I want to go one more. Alright. If a ray divides an angle into two congruent angles, then the ray is an angle bisector. I then give you a second statement. Okay? And I want to know, does this second statement match the hypothesis? Okay? Now, I asked this in one class earlier today, and they said no. But I want you to think about it.
Yeah.
Here it says a ray, right?
Yeah.
Doesn't specify that we have to have a specific name. Is this a ray?
Yeah.
Okay? This says divides. Does this say divides? Here it says an angle. Is angle ARB an angle?
Yeah.
Yep. Up here it says into two congruent angles. Is this two congruent angles?
Yeah.
Okay. So do the objects that I have highlighted, do they match?
Yeah.
Yes. Okay. So we do have the law of detachment here, and now the thing we're talking about. Okay. Here it says a ray divides an angle into two congruent angles. Then that ray is an angle bisector. So down here, the ray we're talking about is RS, right?
Yeah.
So what can you tell me about ray RS? It's a what? It's an angle bisector because it wrote angle ARB into two congruent parts. Is that right?
Yeah.
Okay. You know, it's to say, if I say if you're a B student, then you get an 89 or 89 to an 80 on a test or a quiz or on the grade card, right? And then I say, Blaze is a B student. You know that he got anywhere from an 80 to an 89 on the grade card, right? Okay. Hopefully you think about that kind of stuff. That's how we think on a regular basis about all the things that we do every single day. Okay? Here, it says if two angles are adjacent, then they share a common vertex. Would you guys agree with that?
Yeah.
Okay, that's part of the definition for being adjacent, right? Is that they have to have a common vertex. Okay, so if I look at that phrase there, that's my hypothesis. And here's my second statement. Okay, does that second statement match to the stuff that I have in yellow? No. Okay, if two angles are adjacent and they share a common vertex, and it says angle 1 and angle 2 share a common vertex. Those two things are not matching. Adjacent is a larger concept than just having a common vertex. Does that make sense? Being adjacent means common vertex, common side, no common interior points. Okay? So those two ideas do not match. So I cannot make a conclusion about angle 1 and angle 2. And here's the reason. Angle 1 and angle 2, if they share a common vertex, okay, they don't necessarily have to be adjacent, okay, because we could have pictures. You know, if this is angle 1 here, and this is angle 2 there they share a common vertex, they're adjacent, all that kind of stuff. But I could also have something like this, okay, where that's angle 1, that's angle 2, common vertex, but no adjacency, right?
Okay? So just because we have two angles that are adjacent, they share a common vertex, and we have angle 1 and angle 2 share a common vertex, angle 1 and angle 2 could be these angles. All right? So we don't know. We don't want to make a conclusion. Okay? So that's the law of detachment. Okay? There's another law. It's called the law of syllogism. And before we even get into what it says, look at this example down here. Okay? It says, if it is July, then you are on summer vacation. If you're on summer vacation, then you work at a smoothie shop. If I piggyback those two things, okay, those two statements, one after another. If it is July, then you're on summer vacation. If you're on summer vacation, then you work at a smoothie shop. If I rephrase and say, if it's in July, what new thing could you tell me? You work at a smoothie shop. Okay? That's a new phrase, right? It's a new phrase that we did not have up there. It's a new if thing. Okay? It's a combination of the two old if things, right? But it's new. And guess what you know? If the first two were true, that one's what?
True.
That one's true as well.
That was on our homework.
This one was?
Yeah.
You sure?
Yeah. It named a bunch of stuff and it said P, orange, and all that.
Okay, we'll come back and I'll talk about those at the end of the period. We have time.
Yeah, it was not hard to
But that wasn't law of syllogism. They're just using the same notation that this has right here. But that wasn't the law of syllogism. I'll talk about that at some point. If we look at what's going on here and what the law of syllogism says this second law allows you to state a conclusion from two true conditional statements. Okay? So these two statements right here, these were both true. These were both true if-thens. Okay? And then my third statement that we're able to conclude, the conclusion we make, uses the hypothesis of one of those original and the conclusion of the other. Okay? And we have to be able to match them up. So, kind of go through an example here that shows us matching these things up. It says, if a figure is a square, then a figure is a rectangle. And if a figure is a rectangle, then the figure has four sides. Okay? Those are both true if-then statements. Okay? What you want to do when you see law of syllogism is the first thing you want to highlight is, I always go to I read the first conditional statement, and I highlight that phrase right there. I highlight the conclusion of the first one, and then I highlight the hypothesis of the second one. Okay? And I ask myself, do those two things match? Okay? Yes. Okay? Those match, so if they match, what I can do is I can create a third statement of the things that I don't have highlighted. So the thing I don't have highlighted right now, kind of walking through this, try to use this red, maybe, or not. Okay, I'm going to read through and create a statement that follows that path. Okay, if a figure is a square, then the figure has four sides. And that's a new conditional statement, because the first two are true, now I know that one's true. Make sense? Okay. Over the bottom one. Okay, think about this. Last class had some issues with this, so make sure you pay attention. It says, if you do gymnastics, then you are flexible, right? Okay? If you do gymnastics, then you are flexible. So I'm going to take the flexible part. Okay, that phrase right there. And I'm going to ask, in the second conditional where it says, if you do ballet, then you are flexible, do the two things that I have underlined, do they match?
No.
No. Okay? They are not word for word the same idea, right?
Yes.
Okay? So, in that form, no conclusion. Okay? But when you say no conclusion there's nothing saying we can't do this. Let me cut some stuff out here to make it a little bit more obvious than what we're doing here. I think everything on my computer is frozen, though. Should probably open some more things up down here at the bottom, huh? It won't let me click, so I'll just kind of talk through it. The next thing you want to do, so if they didn't match up that way, okay, that conclusion, okay, that top conclusion did not match the bottom hypothesis. Sorry. It's awesome that this is the class that I'm taping, too. What? Yeah. Randy, be nice. We want to take, if these don't match up in that order, that conclusion, okay, that last conclusion and this hypothesis, okay, if they don't match up, the next thing you want to do is see if this conclusion, trying to highlight, okay, so that conclusion, does it match that gymnastics hypothesis? Okay, and they do not. So the red parts don't match up, so there's no conclusion there. And the green parts don't match up, so there's no conclusion there, right? So overall, no conclusion. Okay? No new statement that can be made. Okay? But if you do, let's say if you do gymnastics, then you are flexible. And then say if you are flexible, then you do ballet. Then you can make a new statement, right here. Yeah.
Right. So why don't you just do, if you do gymnastics, then you do ballet? It's like, they're both flexible.
They're both flexible, but just because I'm flexible doesn't mean that I do both those things. Okay? If those are true statements, if you do gymnastics, then you are flexible. And then if that's true, if you do ballet, then you are flexible, and that's true. When I put them together, or try to put them together, one of those does not piggyback off the other to make a new statement. Okay? They both give me the same thing as being flexible, right? Okay? But just because nowhere up there does it say that because I'm flexible, I can do gymnastics, or because I'm flexible, I can do ballet. Does that make sense? Maybe I can answer that question a little bit better when we go to the next one. Which is